Hi students, welcome to the video lecture 1 on the topic Transient Heat Conduction, which is taken from module 2. Today's class will study what do you mean by transient heat conduction, what do you mean by lumped body and lumped system analysis. So before studying transient heat conduction, so let us study what do you mean by this steady state. So this steady implies no change with time. So I have written here dt by dt is equals to 0. So this capital T indicates temperature, this small t indicates time. That is, there is no change in temperature with respect to change in timing. For that purpose we have done here dt by dt is equals to 0. So in the first module, we have solved the derivations, we have solved the problems by assuming the steady state. That means temperature within the solid was only a function of position, but it does not depend on time. But however, all the process equipments used in the used in engineering practice such as boilers, heat exchangers, regenerators, etc. have to pass through an unsteady state in the beginning and the process is started, and they reach a steady state after sufficient time has elapsed. So this unsteady state, there is a change in temperature with respect to change in timing. For that purpose we have written here dt by dt is not equals to 0. So let us study this with the example. So let us consider a copper ball. This is a copper ball which is at a uniform temperature. So uniform temperature means temperature at all the points within the body should be same. So this copper ball, it is maintained at a higher temperature. Let us say that this copper ball is at 100 degrees centigrade at point A. So these are the different points within the body. I have marked a point A, point B and point C and point D within this copper ball. So the temperature at point A is 100 degrees centigrade, temperature at point B is 100 degrees, temperature at point C is 100 degrees centigrade, temperature at point D is 100 degrees centigrade. So when this copper ball, which is maintained at uniform temperature, when this copper ball is quenched in a water medium which is maintained at 30 degrees centigrade, then the body loses heat to the medium. So here heat flows by conduction within the body to the surface and then from surface to the water medium by convection. So let us assume this process has taken place at a time t equal to 0 seconds. 0 seconds means at present. At present, this copper ball which is at 100 degrees centigrade, it is quenched in a water medium which is at 30 degrees centigrade. So here heat flows by conduction from within the body to the surface and then from surface to this water medium by convection. So if I will measure, see here, so all these bodies are not different. All these bodies indicates this same copper body only, but at different timings. So what will be the condition of this copper ball at different timings? In order to show that, we have drawn these 5 sketches, but these are not the different bodies. This is a single body only. So if I will measure the temperature after t equal to 10 seconds, at point D the temperature is at 90 degrees centigrade, at point C, B and A it is at 100 degrees centigrade only. So again after 10 seconds, if I will measure the temperature of the body at point D, it is at 80 degrees centigrade, at point C it is 90 degrees centigrade, and at point A and B it is at 100 degrees centigrade only. So again after 10 seconds, if I will measure the temperature of this body, at point D it is 70 degrees centigrade, at point C it is 80 degrees centigrade, at point B it is 90 degrees centigrade, at point A it is 100 degrees centigrade. So if we will measure the temperature of this copper ball after 40 seconds, at temperature at point D is 60 degree, at point C it is 70 degrees centigrade, at point B it is 80 degrees centigrade, at point A it is 90 degrees centigrade. So by seeing these sketches clearly, I can write that this temperature T, it is a function of position and it is also a function of timing. For that purpose, we have written here temperature T, it is a function of X, Y, Z and T. This X, Y, Z indicates positions or the coordinates, whereas this small t indicates the timing. See here, at a time t equal to 0 seconds, at point A, B, C and D, the temperature was at 100 degrees centigrade. So after some 40 seconds, the temperature at point A is 90 degree, at point B it is 80, at point C it is 70, at point D it is 60 degrees centigrade. So the temperature is going to change, or the temperature changes along with its positions. And at point A it was at 100 degrees centigrade, so after 40 seconds the temperature at point A is 90, the temperature at point B is 80. So we can tell that temperature T, it depends or it is a function of positions as well as timings. For that purpose I have written here, copper ball being quenched in a water, it goes through the temperature variations with both position and time before it attains a steady state. So the conduction heat transfer in such an unsteady state is known as transient heat conduction or unsteady state heat conduction or time dependent heat conduction. So all these three meanings are same only. So now let us study lumped system analysis. So let us consider a copper ball which is at high temperature. So this is a copper ball which is at a high temperature. Let us say this copper ball is at 100 degrees centigrade. So it is also a uniform temperature body. That means temperature at all the points within the body is same. So here heat flows by conduction from within the body to the surface, from surface to this oil medium it is by convection. So when this copper ball, when it is quenched in an oil medium, here this heat flows by conduction from within the body to the surface and from surface to this oil medium by convection. Suppose if we will consider this copper ball is a very small body, or the thermal conductivity of the material of the body is very large. That means temperature gradients means the change in temperature within the body is very small and hence it is neglected. That means temperature T, it is a function of only timing. Temperature, it does not depends upon the positions, because when we consider this copper ball as a small body, the temperature gradients within the body, there is a change in temperature within the body at different positions, but the temperature gradients within the body are very small and hence it is neglected. So we can see here at t equal to 0 seconds it was at 100 degrees centigrade when it is quenched in an oil medium. So if I will measure the temperature after 30 seconds, the temperature of the body reaches at 80 degrees centigrade. That means even though the temperature gradients within the body are there, but they are very small and hence they are neglected. That is, the whole body acts as a lumped body. What do you mean by lumped body? Means temperature of all points within the body decrease uniformly. Here it is quenched. That means the temperature of the body is decreasing here, or the temperature of the body may increase if the object is being heated. So here the object is being cooled. So after again some 10 seconds or 20 seconds, if I measure the temperature of the body after 50 seconds, the temperature of the body may have reached at 50 degree centigrade. But the temperature at all the points within the body should be uniform, irrespective of its x, y and z directions respectively. So I can clearly write here heat transfer process from the body in this case is controlled by convection resistance at the surface rather than by conduction resistance in the solid, because the temperature gradients within the body we are neglecting here. For that purpose I have written here heat transfer process from the body in this case is controlled by convection resistance at the surface rather than by conduction resistance in the solid. So such an analysis where the internal resistance of the body for heat conduction is negligible and the whole body may be treated as lump as far as temperature increase or decrease is concerned is known as lumped system analysis. So whenever the body we have considered a very small body, that means we are going to neglect the temperature gradients within the body, because the temperature gradients within the body are very small and hence they are neglected. For that purpose we are writing here temperature T, it is a function of only timing, it is independent of the positions. So when the temperature T is only a function of timing, then such a body we are considering it as a lumped body.